Hey everybody, I'm going to show you how to set up a stratified random sampling design using ArcGIS Pro. This is an example. This map is down in Florida, and this is a site where we want to go out and do some sampling of rare plants. And to do that monitoring, we want to set up 1 acre hectare sampling grid within this area of interest. This was set up because these plants are in the dry areas versus plants that would be in the wet areas. So I drew in roughly the monitoring areas that are dry versus the rest of the area or site that is wet. So within these monitoring areas, we want to set up a grid of 1 acre or 1 hectare squares. To do that, we're going to go to our analysis, tools, and we want to look for what's called fishnet. That's what ArcGIS calls the grid tool. Let's say we want our grid to be called sampling grid. There's no space in the name since it has to be, it's going to be going into our geodatabase, which does not allow spaces. We're going to use the monitoring area as the extent. So we want to make sure we have a grid for the entire monitoring area. So the projection I'm using here is a NAT 83 for Florida. It's a state projection system that uses meters as the unit of measure, and 1 hectare is a 100 by 100 meter size. In my case, I don't want label points to be created. What that would do is create a point at the center of each of your 1 hectare squares, which might be a good way to do things if you're not trying to do random sampling, but rather a grid sampling method. In our case, we want it to be random, so first we're going to all we care about is having the square set up at the moment. You don't want to use polyline. You need to use polygons so that you're going to set up an area rather than just having a grid of lines. And we're going to run. So what this did, it created all of our 1 acre hectare sites, but it's in a large square that is inclusive of our monitoring areas but goes well beyond it. So all of these 1 acre plots that are not within our area of interest, our monitoring area, we want to exclude those. So to do that, we're going to select layer by location. For our input area, we're going to use the sampling grid. There's a couple of different things that you can choose. First, I'm going to say we want the sampling grid that's within our monitoring area. But there's a whole bunch of different things that you can choose in terms of a relationship. I'm going to start with intersect because that one would typically make the most sense. I'm just going to select 1 meter, which means if the intersection goes within, if it's within 1 meter of the edge of the monitoring area, it will be included. So let's run. All right, so it's pretty close, but now it's done something that maybe was unexpected. It's included in the selection all of these squares up here, which are only very slightly within our area of interest here, our monitoring areas. We don't really want these to be included. So the next one that you might think would make sense would be completely within. And what that'll do is the opposite issue. You can see there's a bunch of 1 acre hectares along the periphery of our monitoring area that is excluded, but that probably should be included in our selection here. And so the one I've found that is best is to say have their center within. And what that means is that the center of the hectare is within the monitoring area. And that gives us a pretty good, it selects pretty closely just the ones that we want to include. All right. Then we're going to right click on a sampling grid, go to selection, and make a layer from the selected features. And then we can turn off just the regular sample. So now we've created a grid, and we want to select random sampling plots within that grid. All right, to do that, we're going to say create random points. All right, in the output feature class, again, this needs to be compliant with a geodatabase, so you can't put a space between sampling and points. The constraining feature class, we're going to use the sampling grid selection that we just created. For the number of points, there's two selections. There's long and there's field. If we look at our sampling grid here, our sampling grid selection, the attribute table, let's put it down here. We could add a field, and then in each of the records put a different number of sampling points that we want for that field, which would make sense if, say, for instance, in this cell you wanted 2 sampling points, but in the next one you wanted 6, and then the next one 4, and 3, and so on. You could select then the field after you'd created one, select that field from your list, from the drop down, and then it'll create that many points in that individual sampling plot. In my case, I just want, let's say, 3 samples randomly selected within each hectare. So I'm going to use 15 meters as a distance between each of my sampling plots. Let's say our sampling plot was a 5-meter circle around a point. You don't want any overlap, and so 10 meters you would not get any, but 15 makes a little more sense because there's going to be some separation in between plots. All right. Since this is for a sampling design, you probably do not want to create a multi-point output. If you have this checked, you'll get all the points, so visually it'll look like what you want. But when you open the attribute table, you'll have a single record, which is probably not what you're looking for, because you probably want to go out and sample and have like separate sample IDs for every different sampling plot. So you probably don't want to click this. It's an option. I'm not exactly sure why it's an option. I'm not sure what use it would have to have a multi-point feature. All right, so we have everything set up. We hit run. It should create all of our points. So within each of our grids, 3 points have been added in random locations that are a minimum of 15 meters apart. And let's just make sure. Measure distance between, let's see, we're at 2 close ones. This one and this one are about 23. Any 2 closer. Within the same plot, no 2 are that close. This one is, all right, these ones are 15.6, so they're still at least 15 meters apart, even though they're in different spots. All right, so this is about the only case where you have sample plots that are closer than 15 meters, because the sample plots themselves are just by random chance ended up that in 2 adjacent plots they end up clustered. But the stratified approach really helps to distribute your samples within the area of interest and avoids overall having, clusters of sampling in one area and no sampling in another area. So now that we know we have all of our points set up and distributed where we want them, it's important to take a look at your attribute table. So this is what you get. So rather than one record, which would have been what you would have got had you selected to create a multi-point output, we have 519 different records. So 519 points. There's probably some cleanup and removal that you could do because maybe some of the points randomly by chance fell outside of the monitoring area, like this point here. So you could go through and maybe delete some of those that don't make sense, or maybe move them in to the edge of the monitoring area, if that makes sense. It's not perfectly random in that case, but better than having clusters. So you can do something else that's probably going to be useful. You could take this attribute table. There's a lot of things you can do with this now that you've got it created. You could select everything and copy, and then come into a book like this and paste all your data. First I'm going to delete and go up here. So now you have all of your points listed, and you could do, this could be your start. You could start putting, species 1, species 2, etc. And then you could put in like counts when you're in the field. So you could fill this table out as you're in the field. You can take, going back to ArcGIS Pro, you could take all of these points, load them into a Trimble GPS unit with a data dictionary, and you could include fields for collecting, say, the number of individuals of each species that's in your sampling plot. You can use your Trimble then to navigate to the point. So you could go out there and walk right to your point, and then when you get there, you could use the data dictionary to collect your data. So you count, 5 individuals of species 1, you can put that right in your data dictionary, and then when you pull it off of your Trimble unit, you could load it right back into GIS. So either way, there's things that you can do that are going to be helpful. Once it's in here and created, it's not just telling you where these points are, but it gives you a tool if you can combine it with Trimble or ArcGIS or Excel to be able to do more with this data. All right, well, thanks for watching, and I hope you all have a good day.